So for number 3, guys, what we're looking at for number 3 is they're kind of walking you through this. They're asking to find the distance between -2, 5. Remember, -2 goes to the left, 5 goes up. So we're going to go -2, 5. Boom. Oh, that's just A. So really what they're doing is they're asking what is the distance from A. And now we're going to go 4, -1. 4, first number tells me to right or left, second number up or down. So I'm going to go to the right 4, down 1. Oh, there it is. So they're asking for the distance between A and C. Okay, so in order to find the distance between A and C, right, we notice that this is a diagonal line. The moment it's a diagonal line means that I cannot count. You can't just go, oh, this is 1, 2, 3. Doesn't work that way, not with a diagonal line. So what we have to do is turn this into a right triangle. It's already a right triangle. So now I got to find A and B. So to find A, we know that we're going to go 1, 2, 3, 4, 5, 6. Oh, okay. So this will be A. You could call it B if you wanted to. It doesn't really matter. So that's 6. And then B is 1, 2, 3, 4, 5, 6. Oh, okay. So B is 6 as well. So now I know, once again, we're going to use A squared plus B squared equals C squared. We know that A is 6. That's what we got right there. So it's going to be 6 squared. B is 6. So I get 6 squared. I do not know what C is. That's what I'm looking. So you can leave it C or you can change it to X. It doesn't really matter. Now remember, once again, this is not 6 times 2. This is 6 times 6. 6 times 6 is 36. We get the exact same thing here. So 6 times 6 is 36. We want to solve for C. So we're going to combine like terms. 36 plus 36 is 72. We are going to take the square root, right? Because I don't want to have C. I want C squared. Or I don't want C squared. I want C. So to get rid of a square, we take the square root. Whatever I do to one side, do to the other. So these will cancel each other out because they're opposites. And then I'm going to take the square root of 72. So the square root of 72, that's going to give me 8.48. You could keep going, but these are the only ones I need to look at. Remember, we are rounding to the nearest 10th. So we're rounding to the first number past the decimal. Okay. So this is a number that's either going to stay or it's going to change. Depends on this. Okay. Remember, if this is 5 or above, it changes. If it's 4 or below, we stay. Okay. So this is obviously 5 or above. So this number needs to change. So I need to round up. So that 4 becomes a 5. The 8 doesn't change. We don't need that number anymore. So now my answer here is 8.5. So now I have the distance there, which is 8.5. Now you can see that they kind of walk us through it. Now we need to find the perimeter. Remember, the perimeter is add all sides. So we already found all the sides. We found this side, which is 6, this side, which is 6, and now that side, which is 8.5. So we're going to go 6 plus 8.5. Just type this into a calculator. We're going to go 6 plus 6 plus 8.5. That's going to give me an answer of 20.5. So the perimeter is 20.5. Okay, that's all the way around. Now to find the area of ABC, remember it's base times height. It's not a rectangle, so we're going to divide this by 2. Okay? So what I'm going to do is I'm going to find the base. Well, once again, the base is the side that it sits on, so it's sitting on this side. So the base is 6. Okay, and now the height, remember the height goes from the highest point straight down. So we're going to go straight down from the highest point in such a way that it forms a 90 degrees. It better form a 90 degrees. If it doesn't, then that's not the height. Well, this one is our height. Okay, it's a 90 degrees. So how high is it? 1, 2, 3, 4, 5, 6. Oh, it's right there. So we're going to go 6 times 4. But now remember, if I were to turn this into a rectangle, that would be the area, but I'm actually cutting this in half. So we are going to cut this in half. So 6 times 4 is 24. 24 divided by 2 is 12. Okay. So now the area of this triangle is 12. The perimeter is 20.5. Okay.